Hello, and welcome to the National Spectrum Consortium Spotlight. I'm Randy Clark. I'm currently the elected vice chairman of the consortium, and today we're here to do a spotlight series with Wind River, and we're fortunate enough to have Mr. Paul Miller, who's currently the CTO of Wind River. Thank you, Paul, for joining us, sir.
Sure, thanks for having me on.
So, Paul, before we get started in the conversation, can you tell us a little bit about what you do at Wind River on a daily basis?
Sure, yeah, glad to do that, Randy. So I'm the Chief Technology Officer at Wind River, and largely I'm responsible for technology and strategy for the company's portfolio of products. In particular, we'll spend a little time, I think, talking today relevant to the NSC. The past couple of years, we've been focused on 5G and intelligent systems at the edge, and they're playing a major role in 5G rollout today in the commercial sector, as well as in other uses for edge compute systems. This, for Wind River, kind of where our DNA is, we really focus on advanced virtualization technology and providing software infrastructure solutions that solve problems in that space for our customers. With our history in the aerospace and defense sector also, as well as others such as telecommunications and autonomous vehicles in the industrial sector, we're seeing a really interesting and amazing convergence of technologies that are relevant to the NSC as we look at the NSC use cases, as well as in the domain overlap between those domains.
Well, I couldn't agree with you more, and I'm so impressed by the work that you stated. Can you describe a little bit more about your legacy within the DoD industrial base, Paul?
Yeah, thanks. We're actually very, very proud to have been in business for a long time, working in that industry. We're a global leader in delivering software for intelligent systems at the edge. For 40 years now, we've been in business, and our technology has been powering a lot of the safest and most secure devices in the world. It's found in more than 2 billion products. And our really purpose and charter as a company is to accelerate digital transformation of critical infrastructure systems that really demand the highest levels of safety, security, and reliability. Within aerospace and defense specifically, our technology is trusted by more than 600 companies, working on some of the most advanced and innovative embedded systems in the world. One of our products, VxWorks, has secured over 440 design wins. It's deployed in more than 80 different aircraft. We've delivered solutions to NASA, Department of Defense, other government agencies, and a broad range of commercial and military aerospace industry leaders that you're familiar with. Across those various defense domains, space, air, maritime, ground, cyber, Wind River software solutions, you'll find them in a bunch of different systems, performing some of the most demanding missions. These would include command and control, communications, computers, intelligence, surveillance, reconnaissance, strike and mobility, as well as even space access and exploration. So a lot of different programs we've been involved in over the decades, and we've got a rich history as a result, but we're also honored to participate in these critical systems that help enable the warfighter and their system needs.
Well, there's no question about that, Paul. It's very impressive body of work. It's obvious that you've got the domain knowledge and the past performance. Can you be a little bit more discreet about where Wind River's sweet spot is in the 5G ecosystem, at least today, and the research that the DoD is doing through the consortia?
Yeah, absolutely. And in order to help you understand how Wind River fits in that space, we're going to take a little bit of a tour of some of our background in the telecommunications domain. So we not only sell into aerospace and defense, but our products are used in other high availability environments. In telecommunications, it's quite normal, for example, to have 5 and 6 nines high availability as the norm. So a lot of the products we offer are a perfect fit for that. As a result, we've been involved in 2G, 3G, and 4G historically, and are now involved in 5G as well. The interesting thing that happened with 5G is that, and a lot of people are focused on the RF technology and use of spectrum. That's pretty typical as you move through the generations of Gs, if you will. But the infrastructure layer has gone through a massive transformation. In the telco domain, there was a real initiative about 7-8 years ago in the core of the network called NFV, which was really the use of cloud technology and to transform them from kind of proprietary specialized equipment to fully cloud-based solutions in the network. As 5G kind of emerged as a technology a few years ago, naturally that industry started looking at using virtualization to solve that problem. And this is where Wind River enters and becomes relevant to 5G. We saw that a lot of the existing infrastructure technologies around virtualization were not going to meet for the need for 5G. Even though the market was moving there and was trying to reuse some of the cloud technologies from the core, as you get to the edge of the network, the whole game changes. The requirements get very different. You start thinking about high performance and low latency. That's very different than at the core of the network. You think about the requirements for telemedicine and autonomous vehicle applications, autonomous drone control, right? You need ultra low latency and high performance at the edge. You need to scale down to a very small footprint. Thus, the requirements that gave rise to the high scale centralized data centers that cloud technology had been in are not a good fit for the edge. So as a result of those new requirements, and continuing, of course, to need high availability and latency and et cetera, we saw that emergence as a real change in the footprint of the cloud. It became geo-distributed. And this is exactly what's happening with the warfighter at the tactical edge. If you look at that infrastructure, ships, planes, vehicles, remote tactical sites, the warfighter themselves at the edge, this is a geo-distributed deployment. And if we look at the challenges solved around 5G to enable geo-distributed technology for cloud, they're equally applicable to that defense problem set. So this, for us, drove the creation of an open source initiative. We founded that with a couple of other companies under the Open Infrastructure Foundation called Starling X. And we took heart those new requirements around the tactical edge and the warfighter and the complex problems of coming on and off grid and making self-healing environments, highly secure topologies, right? Zero touch deployment and the low scale problem. And those requirements fed into that new open source activity. That's resulted in a product we call Wind River Cloud Platform that we downstream from that open source project. It is a Kubernetes-based framework, but it's designed to solve the problems we've just been talking about. That has also resulted from the 5G space in the commercial sector where 5G has started. We've been selected for deployment by one of the tier one operators in the United States for their entire national deployment of 5G. And we also do work in private 5G and in building 5G solutions. So kind of a long tour there, but we really feel that the foundation that we've built in 5G for the commercial sector and the problems in history and experience we have around solving problems for the warfighter, we'll be able to take our company DNA and apply that exact same technology and enable it for the applications that the DoD is focused on.
I couldn't agree with you more. Talk about skating to the puck and being at the right place at the right time. You definitely have the past performance and definitely have the domain knowledge to be a critical value add to enabling current new capabilities and closing current capability gaps for our warfighter. There are a lot of challenges to overcome in successfully deploying 5G. As example, we have the compromise of the microelectronic supply chain, right? How do we assure the integrity of software through attestation? We have the size, weight, and power unique requirements at the tactical edge. We have low probability of detect, low probability of intercept. A lot of the features of 5G in the current and future releases are going to help mitigate a lot of that. But from your perspective, what are the short-term challenges to a successful deployment of 5G for the DoD?
Yeah, so that's a really interesting space. And you know, as a technologist, you can often be focused on the technology requirements to implement the systems that meet those requirements, right? And we've talked about high availability and geo redundancy and low latency and all these things that enable you to build a 5G system. But fundamentally, because we've also talked about it being a totally different animal, it's geo distributed, it's super high scale, it's got tens to hundreds of miles separating nodes within the network. The real problem comes about because of the complexity of that system, and that turns into an operational problem. So where I'm taking you is that, yes, we'll solve the technology problems, a lot of vendors will. The real key, though, is enabling it to be operationally friendly, right? How can you run a highly distributed system like that in a secure manner where lives are on the line at the, for the warfighter at the tactical edge? How do you solve those problems? And we believe the key to that is a lot of software automation and control through applications like automated orchestration to manage the applications. And in particular, the introduction of advanced big data and analytics systems that can run AI and ML algorithms that can enable things like predictive outage avoidance and predictive analytics. And they're really critical as you look at such a complex, large topology where we're bringing the entire tactical domain underneath one architecture to host these different software applications. I think it was the chief software officer of the Air Force that often talks about the desire to have an airplane land with different software than when it took off, right? And you're not going to rely on human for oversight for this infrastructure. So having that automation and the assistance from AI is really critical to solving some of these problems.
Paul, what a great conversation. Unfortunately, we've run out of time. So many astute observations that are so relevant to guiding the community forward in developing the right technologies, the sustainment models, the AR algorithms to enable the hyper-connected dismounted warrior to make, for the network to make multiple decisions in the amount of time that it takes a soldier to blink their eye. Fundamentally 250 milliseconds. We're talking about compute speeds that are a millisecond latency. So the question is, how many decisions will the network make autonomously in the amount of time that a human can blink their eye? With that said, Paul, I am so appreciative of your time today, your expertise, your willingness to participate in our community and help for a common goal. For that, I thank you, sir. Today, if there are follow-up questions that you have for myself or for Paul, please feel free to reach out to us. We'd be more than happy to engage in further conversations. So with that said, Paul, thank you very much for your time, sir.
Yeah, thanks for having me. It's great.
Absolutely.